Welcome to the very first episode of Deconstructed. In this series, we'll be taking different games and trying to recreate them in Unreal Engine. You can probably already tell by the title, but this time around, we'll be trying to recreate New Super Mario Bros. Wii. I started off with the third-person template because it was the closest thing to what we're looking for, which is a 3D side-scroller, or as some people call it, a 2.5D game. The first thing I did was go into the third-person blueprint and change the gravity amount so it would feel more like a Mario game and less realistic. Once I was satisfied with the gravity, I went ahead and started clearing out the map so I could prepare to make my side-scroller level. I then immediately created an actor that will be used for my camera. This camera is going to follow the player around. It's not going to have any of the fancy zoom dynamics, but I'll probably add that in a later episode. In my camera actor, I then just added a camera component and then a spring arm. I then attached the camera to the spring arm so that the camera follows the spring arm. I then placed the camera actor in the world and then rotated towards where I wanted my player to be at. Now that I had my camera actor set up, it was time to make the logic. To do this, I used the set view target with blend node, and then I grabbed a reference from the world of the camera actor, and then set that as the new view target. I then grabbed a reference to the player controller and set that as the target. This ensures that the player still can use their character even with the new camera activated. And voila, we have the follow camera active, except there's one problem, it's not following, so I have to go back and set the logic up for that. But before that, I went back into the map and I deleted the wall that will be between the camera and the player, and I deleted the wall that will be where the player will be advancing towards. I then went back into the blueprints, got the player character as a reference, and then got the location of the character. I'll be using this to set the location of the camera the same as the player. No matter where they're at, the camera will follow them. So as you can see, I used the set actor location node, and then I took the Y location of the player and then plugged it into the Y location of the camera so that they stay aligned with one another and the camera actively moves as the player moves. After that, I got the camera's location and plugged the X and Z values into the new camera location. That way the X and Z remains untouched while the Y pans along with the character. And there we have it, the camera now follows the player. The only issue is the player can still move in 3 dimensions. I'll probably end up going back in a future episode and making the camera move more dynamically, but for now, let's just fix the movement of the player. Before that, I wanted to organize really quickly. I made a separate event graph for the events I just made. I like to usually organize my custom events separately from the pre-made events, and I usually like to split my event graphs into multiple event graphs depending on the category. So for this one, you can see I labeled it camera controls, and it's always nice to add comments on there. It's just good practice. But now it's time to take away the 3-dimensional controls and ensure the character only moves in 2 directions, in the X or Y direction. To start, I disconnected the forward and backward controls. The issue I was having here was the character was still following the rotation of the mouse, so I went and I disconnected the look control as well. I then went and deleted all the excess controls that had been disconnected, but I did have one problem, which was that my left and right were inverted, and I'm going to show you guys how I fixed that in just a second. So my cheap fix to the inverted controls was to take the right vector and negate it, which kind of inverts it, and then I plugged that into the movement input, which properly aligned the left and right. Now things are looking good, but there was one pet peeve I had, which was that you could make the player face the front, which isn't really a thing you see in New Super Mario Bros. Or a lot of side scrollers in general, or you can't do it by yourself at least, like maybe during idle screens, but I want to get rid of that, so that's what I'm going to do next. The first step I took to approach this issue was using the event tick to kind of debug which rotation I felt like was facing too much towards the camera. So I didn't want to just eliminate front facing, but anything that was within the proximity of front facing as well. So to do that, I got the active rotation along the Z axis, and then I printed it to the string every delta second to show where the user was rotated at any given moment, just to see which rotations I felt like were too much. If you look in the top left, you can see the rotation along the Z-axis. I ended up deciding that around 45 degrees negative and positive direction was where I would draw the line, which kind of makes sense because it's about half turned. But now it's time to implement the actual logic. Now forgive me, I was a bit back and forth on this, but that's because I didn't really have any references. I've done this before, but I didn't refer to it. I just kind of did it as a freestyle, so it kind of was a trial and error thing for me. So the first thing I did was go to my event graph for the basic controls, and I created a condition that checked if the rotation on the Z-axis was between either 0 and 45 degrees or 0 and negative 45 degrees. Now if the rotation was between either of those values, it would set it at the limiting value, which in the positive direction would be 45 degrees and the negative would be negative 45. So just at the edge of where I felt like was too much rotated towards the front. I also went ahead and plugged in the default actors rotation to the X and Y, just so that it maintains the rotation along the X and Y and only changes the rotation on the Z axis. Here I'm just copying the setup in the positive direction. I then went ahead and plugged my custom event into my event tick. As you can see, my setup wasn't working here, but that's because I set the default rotation to be negative 45 degrees in both positive and negative cases. Another issue I had was whenever I started the game, the player would automatically be facing in the front facing range, so I had to add the condition to check to make sure that the player had already been moving before trying to force the rotation to be at the limiting rotation. And right now you can see it isn't forcing it to face the right side every time, but it is still snapping to the right, but that's because I had it set at the wrong value for the positive rotation fix. Here you can see I started to realize why we're wrong, so I just quickly fixed it, compiled it, and then went back to testing. Here you can see my logic is working, but it's very snappy with the rotation. So what I'm going to do is use a R interp tool, which interpolates the rotation and generally just makes it smoother. So after I got the R interp 2 node, I got the active rotation, plugged in the original rotation to the current, and then plugged in the desired rotation to the target, which was the same rotation minus the updated Z. I then plugged in the get world delta seconds for the delta time, and I did play around with the interp speed, but in the end, it was 10 that ended up working the best for me. Here I just recombined the rotation pins for the set active rotation and plugged the R interp 2 output into it so that it smoothly sets the active rotation instead of instantaneously. I then just followed the same procedure for the other direction. And then it never hurts to organize, so did a little bit of organizing and it was time to test again. Now the logic was working, but initially I started with the interp speed at 0.05 and that was extremely slow, so I went back and tested 10, which ended up being my final interp speed. And voila, as you can see, the player no longer faces the front directly, and if it does, it smoothly rotates to either direction. Then went back, organized, and commented on all of my events. I'll try to stay in the habit of doing that. It's just good practice for whenever you're working on projects on a team or by yourself, just to keep things organized and easy to understand. I also kind of just panned through everything slowly just to make sure you guys seen how I did everything, because I know I was kind of back and forth and kept changing things, but all in all, this is what I ended up with. Now this step is completely optional, but I went to the mannequin skeleton and decided to add a hat socket to add a bit of cosmetic to it, make it feel more like a Mario game. Nintendo, please don't sue me. But I also wanted to be able to distinguish between different power-ups as I progressed through the series, and I figured what better way to do that than some sort of hat maybe. So I added a socket to the head bone and called it hat socket. I then added a preview mesh as a hat I downloaded from models resource, I believe, and just adjusted it to make it actually fit like a hat. I then went into third-person character blueprint and attached the hat to the skeletal mesh, and then attached the hat to the socket through the components, and then made sure it fits snug on the head like an actual hat. This is what the character looked like with the hat on, and this is the final product of episode 1. As you can see, we have our 2.5D setup, we have our hat set up, and we have our rotation fixed. Until next time, thanks for watching.